For years, America was told that the electric vehicle war would be won by the company with the biggest battery, the longest range, and the fastest charger. That belief shaped everything from Tesla's supercharger confidence to Detroit's electric pickup strategy. But on the other side of the world, NIO is testing a colder idea. What if the future is not about charging the battery faster, but removing the waiting entirely? NIO says its power network can complete a fully automatic battery swap in about 3 minutes. And by February 2026, the company announced it had already passed 100 million cumulative battery swaps. During China's May Day travel rush in 2026, reports said NIO's swap stations completed more than 1 million swap services in just 7 days. This is no longer a showroom trick. It is infrastructure behaving like a weapon. Because the real enemy of the American electric truck may not be range, it may be downtime. And if a driver can replace energy faster than a Ford F-15, Lightning can realistically recover it at a rural fast charger, then Detroit is not just facing a new EV feature, it is facing a new definition of highway power. To understand why battery swapping feels so disruptive, you have to understand the story America was told first. For more than a century, the American driver did not think about energy as a technical event. Gasoline made refueling invisible. You pulled into a station, filled the tank, bought a coffee, and left. For pickup owners, contractors, road trippers, and families crossing state lines, that rhythm became part of the national driving culture. The vehicle could be large, heavy, inefficient, or loaded with tools, but energy came back quickly. Then Tesla changed the electric vehicle conversation. It did not simply build cars with batteries. It built confidence around the idea that charging could become predictable, mapped, automated, and fast enough to support real travel. Tesla now describes superchargers as the fastest charging option away from home, capable of adding up to 200 miles in about 15 minutes, and says its global network has more than 80,000 superchargers. That mattered because Tesla gave EV buyers something earlier. Electric cars lacked the feeling that the road would not end where the battery ended. Detroit learned from that lesson, but it translated the answer through truck culture. If Americans feared range, Detroit gave them larger packs. If they worried about power, Detroit gave them instant torque. If they doubted electric pickups, Ford put the F-150 name on a battery electric truck and offered an EPA estimated available extended range of 320 miles on the 2025 F-150 Lightning. GM pushed the Silverado EV toward even larger range claims, while Ram explored the range extender path with the Ram Charger. The message was clear: the electric truck would become acceptable when it looked strong enough, went far enough, and promised enough capability. But there was a blind spot hidden inside that strategy. A large battery can delay a stop, but it does not erase the stop. A fast charger can shorten waiting, but it still asks the vehicle to sit still. And for an American truck owner, sitting still is not a small detail. It is the lost hour on a workday. It is the trailer blocking a charging stall. It is the cold Michigan morning when charging slows down. It is the rural highway stop where the charger is occupied, broken, or too far off route. This is the opening NIO is attacking. Battery swapping does not try to make the plug more heroic. It questions whether the plug should be the center of the system at all. If the pack can be removed from beneath the vehicle and replaced by a charged one in minutes, then the EV stops behaving like a phone that needs to wait by the wall. It begins behaving like a logistics machine where energy is stocked, rotated, inspected, and redeployed. NIO says its power swap system can complete a fully automatic battery swap in 3 minutes, and its 100 million swap milestone signals that this is no longer an experiment hiding in a laboratory. It is a real infrastructure thesis. That is why this story matters beyond NIO. The question is no longer whether an electric truck can carry a big enough battery. The question is whether America is building the right energy system around that truck. Because if the next EV war is decided by the company that gives drivers their time, Back then, the old race for range may already be too narrow. The first pillar is physics. A gasoline pump moves liquid fuel into a tank quickly because it is basically transferring stored chemical energy from one container to another. An EV charger is doing something more delicate. It is pushing electrical energy into a battery through cells that must manage heat voltage, current state of charge, and long-term degradation. That is why the first 10 minutes of charging can look impressive, while the last stretch can slow down dramatically. The charger is not just filling a box, it is negotiating with chemistry. The legacy answer has been simple: raise charging power, grow battery capacity, and build more fast chargers. That is the logic behind America's current EV highway plan. But NIO's battery swap model attacks a different variable. It does not try to force electricity into the pack faster. It removes the depleted pack and replaces it with a charged one. NIO describes its power system as using chargeable, swappable, and upgradable batteries, and the company says it has already passed 100 million cumulative swaps with 3,790 power swap stations worldwide and 1,020 along major highways in China. Now put that into an American scene. You are towing a trailer through Colorado. The grade is steep, the air is thin, and the battery is draining faster than the dashboard promised. A 350 kilowatt charger sounds powerful on paper, but if you have to wait for a stall, unhook a trailer, manage the charging curve, and lose half an hour, the number on the charger becomes less important than the number on the clock. Battery swap turns that clock into the battlefield. The second pillar is ownership. In the American EV model, the battery is treated like a permanent organ inside the vehicle. You buy the truck, and inside that price, you're buying the heaviest, most expensive, most degradation-sensitive component in the entire machine. That makes sense if the battery is viewed as a fixed part of the product. But battery swapping changes the philosophy. The pack becomes less like an engine block and more like an energy cartridge in a controlled industrial system. This is where battery as a service becomes dangerous for Detroit. If the customer does not have to think of the battery as a permanent asset, the entire purchase equation changes. The car can be separated from the energy pack. The pack can be leased, upgraded, inspected, reused, and recycled through the network. The driver is no longer only buying transportation. The driver is entering an energy infrastructure contract. For a Ford F-15, Lightning owner, the battery is inside the truck, and the truck must go to the charger. In the NIO model, the battery is also inside the vehicle, but only temporarily. That changes the psychology. It asks whether the most valuable part of an EV should be privately owned by the driver or centrally managed by the network. Detroit sells the battery as part of the truck. NIO is trying to turn the battery into a service layer. The third pillar is standardization. Battery swapping only becomes powerful when the pack is not trapped inside one model, one platform, or one brand. If every automaker uses a different pack shape, bolt pattern, cooling interface, voltage, layout, and software handshake, then swapping becomes a boutique feature. It works for a small fleet, but it cannot become highway infrastructure. This is why the CATL connection matters. Reuters reported in March 2025 that NIO tied up with CATL to develop a battery swapping network, with CATL supporting NIO through its Choco Swap technical standards and network, and investing up to 2.5 billion yuan in NIO power. That is not just a battery supplier helping a car company. That is the world's battery industrial base moving toward infrastructure control. Now compare that with the United States. Ford has its electric truck architecture. GM has its own battery platform strategy. Tesla has its own tightly integrated vehicle ecosystem. Stellantis is building around its own frame and electrification plans. That protects brand control, but it also fragments the infrastructure problem. If China moves faster toward battery swap standards, while the US protects individual platforms, the fight may not be vehicle against vehicle. It may become standard against standard. This is the hidden danger. A single NIO station does not scare Detroit. A common battery architecture supported by automakers, battery giants, and infrastructure partners should. Because once the pack becomes standardized, the station is no longer a convenience stop. It becomes a gatekeeper. The fourth pillar is logistics. A fast charger is a power event. It asks the grid to deliver a large amount of electricity to the vehicle in a short window. A swap station is different. It can treat batteries like inventory. Packs come in depleted packs, go out charged, and the station can manage charging speed, temperature, battery health, and energy timing behind the scenes. To the driver, the stop looks like a 3-minute service. To the operator, it is a rolling warehouse of stored electricity. That matters because highway energy demand is uneven. Holiday travel creates spikes. Morning commuters create spikes. Truck routes create spikes. Rural corridors create weak points. NIO's recent May Day performance showed the scale of this logic. Reports said its swap network delivered more than 1 million battery swaps during China's holiday rush, while Tech Radar reported that NIO operated 3,843 power swap stations and delivered 15.4 gigawatt hours of energy between May 1st and May 5th. And this is not staying inside one company. Reuters reported that CATL and Sinopec plan to build 10,000 battery swap stations using CATL's ChocoSwap technology and Chiji chassis battery swapping solution for passenger vehicles and heavy-duty trucks. That detail matters for America, because when an oil giant, a battery giant, and EV platforms begin converging around swap infrastructure, the comparison is no longer NIO versus Ford. It becomes energy logistics versus plug-in charging. Picture a Texas highway in July. A line of EV pickups pulls into a charging plaza, each one asking for high power at the same time. Now picture a swap site stocked with charge packs replacing energy, like a distribution center moves pallets. One system waits for electrons to enter the vehicle. The other moves the energy container itself. That is the engineering split. This is why battery swapping should not be dismissed as a gimmick. A gimmick lives on a demo stage. A logistics system lives or dies by repetition. And NIO's argument is built on repetition, station after station, pack after pack, swap after swap. Once that rhythm becomes normal, the driver stops asking where to charge. The driver starts asking why charging ever required waiting in the first place. Now compare that swap logic with the American benchmark, the Ford F-150 Lightning. This is not just another EV. It carries the nameplate that helped define the American pickup century. Ford says the 2025 F-150 Lightning Lariat offers up to 320 miles of EPA estimated range. On paper, that sounds respectable, but the question battery swapping asks is not whether 320 miles is enough on a perfect day. The question is, what happens when that truck is towing cold-loaded or far from a reliable charger? Chevrolet pushes the range argument even harder. GM Fleet lists the 2026 Chevrolet Silverado EV 8WT with an EPA estimated range of up to 493 miles, up to 10,500 pounds of maximum available towing capacity, and up to 1,400 pounds of payload. That is the American answer in its strongest form. Build a bigger electric truck, give it a bigger battery, and stretch the stop farther down the road. But even that does not eliminate the stop. It only postpones the moment when the driver must find power again. Ram's range extended strategy reveals the same anxiety from another angle. Ram says its range extended electric truck is projected for 2026 availability and claims up to 690 miles of driving range with up to 14,000 pounds of towing capacity. That is not a rejection of electrification. It is an admission that full-size American truck buyers still fear being trapped by infrastructure. Ram is not only selling range, it is selling an escape hatch from charging dependence. Then there is Tesla, the strongest American counter-argument. Tesla's supercharger system remains the most powerful proof that plug-in charging can become a real travel network. Tesla says superchargers can add up to 200 miles of range in 15 minutes with charging rates up to 325 kilowatts. That is impressive. But it still keeps the vehicle connected to a cable, still depends on charger availability, and still treats energy recovery as a waiting event. That is where Jeep becomes symbolically important. A Jeep Wrangler owner does not buy into the idea of freedom just to plan life around a plug. The Wrangler mindset is remote trails, bad weather, dirt roads, and independence. Battery swapping is not ready to replace that culture in America yet, but it raises a brutal question. If even the strongest charging networks still require waiting, could a future off-road or adventure EV need a different energy model entirely? So this is not a clean fight between NIO and Ford or China and Detroit. It is a fight between two definitions of convenience. The American benchmark is range towing payload horsepower and charging speed. The swap benchmark is time, and time may be the one metric no spec sheet can hide. The economic impact begins with a simple question: who owns the battery after the vehicle leaves the factory? In the traditional American EV model, Ford, GM, Tesla, or Stellantis build the vehicle, sell the pack inside it, and then the driver becomes responsible for living with that battery for years. The battery is a product component, but in a swap-based system, the battery becomes an infrastructure asset. It can be tracked, rotated, inspected, leased, retired, reused, and recycled by the network. That shifts value away from the individual vehicle and toward the company that controls the energy system around it. That is why CATL matters so much in this story. Reuters reported that CATL agreed to support NIO's battery swapping network through its Chaco Swap technical standards and network, while making a capital investment of up to 2.5 billion yuan into NIO Power. KTL is not just a battery supplier in this equation. It is moving toward the layer above battery manufacturing standards, infrastructure, energy services, and lifecycle control. And when the world's largest EV battery manufacturer begins backing swap standards, Detroit cannot dismiss this as one Chinese automaker's experiment. The geopolitical angle becomes even sharper when oil infrastructure enters the frame. CATL and Sinopec have announced plans to build 10,000 battery swap stations, including solutions for passenger vehicles and heavy-duty trucks. That is not a small pilot. That is an attempt to turn swap stations into a national energy layer using existing fuel station logic and battery logistics at the same time. For the United States, the warning is clear. The next EV infrastructure race may not only be about charger count, it may be about who controls standardized battery circulation across highways, fleet cities, and freight corridors. Tariffs can slow vehicles at the border, but tariffs do not automatically stop an infrastructure idea from spreading. If battery swapping proves useful in dense corridors, taxi fleets, logistics fleets, or heavy-duty routes, the model can travel through partnerships, standards licensing, and battery suppliers. The United States may block the car and still face the architecture. That is the uncomfortable part. Industrial power is not always exported as a finished product. Sometimes it is exported as a system other countries begin to copy. This also changes the labor question. The old debate asks who will assemble the EV truck. The new debate asks who will operate the battery network. The pack warehouses, the swap stations, the inspection systems, the recycling channels, the software that measures battery health, and the service crews that keep the highway energy system alive. For union labor in Michigan, Ohio, Kentucky, and Tennessee, that matters. Future automotive jobs may not only sit inside assembly plants, they may sit inside the energy infrastructure that surrounds the vehicle. And investors will notice. A normal automaker is judged by vehicle deliveries margins, incentives, and production scale. But a swap network operator can be judged by different numbers: station utilization and battery leasing revenue, energy throughput, pack lifecycle value, software control, and recurring service income. NIO's 100 million battery swap milestone, with 3,790 power swap stations worldwide and 1,020 along major highways in China by early 2026 points to a business model that is not only selling EVs, it is trying to monetize motion itself. So the question is not whether America should copy NIO station by station. That would be too simple. The real question is whether America understands what is being tested, a world where the battery is no longer just a component, but a strategic infrastructure layer. If China turns the battery into infrastructure before America does, how should the US respond with better chargers, or with a completely different industrial plan? Detroit has survived revolutions before. It survived foreign competition, fuel crises, emissions rules, factory automation, and the rise of Tesla. American engineering is not weak. American manufacturing is not finished. But every industrial empire becomes vulnerable when it mistakes the last war for the next one. The old EV war was about range, then it became about charging speed, then it became about charging networks. But battery swapping introduces a harder question. What if the winner is not the automaker with the largest battery, but the system that gives drivers their time back? NIO's claim of a 3-minute fully automatic swap and its 100 million cumulative battery swap milestone by early 2026 show that this is no longer only a concept on a trade show floor. It is a working infrastructure thesis, and the warning becomes sharper when CATL enters the picture. When a battery giant supports swap standards, invests in NIO power, and joins broader plans for thousands of swap stations, this stops looking like one company's gamble. It begins to look like a coordinated attempt to turn the battery itself into infrastructure. So Detroit should not ask whether American drivers will accept NIO tomorrow morning. That is the wrong question. The real question is whether the United States is building an energy system fast enough, flexible enough, and industrially deep enough for the next phase of electric mobility. Because the next EV war may not be fought inside the vehicle. It may be fought underneath it, where the battery stops being a component and becomes the battlefield.